Hello teacher, hello students. This is a tutorial series which is organized by Oromia Education Bureau on mathematics, and I am Dr. Garuma Abdisa from Matu University. Today we are going to have a look at rationalizing the denominator of a given mathematical expression which has on its denominator an irrational number. As you can see, for example, in this case, 1 is a rational number, while square root of 3 is a rational number. So our purpose is to convert the whole expression, which is 1 divided by root 3, in such a way that the denominator of this mathematical expression will only consist of a rational number. In order to achieve this, because 1 in mathematics is a multiplicative identity, means multiplying a given mathematical expression by 1 always yields the same thing. So what we are going to do is we multiply 1 over root 3 by root 3 over root 3. As you can see, this expression, which is in this parenthesis or in brackets, is equivalent to 1, means root 3 divided by root 3 is already equal to 1. So 1 divided by root 3 times 1, namely root 3 divided by root 3 will rationalize the denominator. Let us do it in a little detail. 1 times root 3 is root 3, that is, we simply multiply 1 by this root 3 in order to get this root 3, and root 3 times root 3 will give us a square root of 9, which is equivalent to 3. So this root 3 times root 3 will be 3. So as you can see here, our given original expression, 1 divided by root 3, is now completely converted into an equivalent expression, equivalent mathematical expression, in which case now the denominator consists only of a rational number as it is denominator, namely root 3 divided by 3. So this is the way we rationalize the denominator of any given mathematical expression. Here is a second problem, which is a little bit more complex and challenging than the previous one, but I hope you will manage to do it by yourself as well. In order to rationalize the denominator of this expression, which is 1 divided by root 3 minus root 2, what makes this problem a little bit different from the previous one is that in this case, now the denominator consists of two irrational numbers. In the previous case, it was only root 3, which was in the denominator, but now both root 3 and root 2. In order to solve this problem, what we do is we use a minus b times a plus b equals a squared minus b squared. We will use this mathematics identity in order to solve this problem. So we wanted to have the denominator of our expression to have this kind of expression, so that its multiplications will consist of the square of two terms, and the square of two terms involving square roots will be rationalized. So let us see it. This is root 3 minus root 2. I will multiply it by root 3 plus root 2 instead of the minus involving here. I wanted to make it a plus. That is to achieve, I have root 3 here and then root 3 there, root 2 and root 2. The minus sign is now converted into plus, so that the expression will look like a minus b and a plus b form. When we do so, the advantage that we are going to take out of it is that a minus b times a plus b will be a squared minus b squared. So 1 times root 3 is root 3, 1 times root 2 is root 2, and according to this identity, root 3 minus root 2 times root 3 plus root 2 will be the square of the differences of the two terms, namely root 3 squared minus root 2 squared. Root 3 squared is 3, that is square root of 9 is 3, minus root 2 squared, square root of 4 is 2. So I will have the terms that you can see here. And 3 minus 2 is simply 1. So the given mathematical expression, that is 1 divided by root 3 minus square root of 2, will finally be equal to just root 3 plus root 2. We can ignore the being divided by 1 here. As you can see, any number divided by 1 is the same. So in this final expression, there is no irrational number appearing as the denominator of the given expression. So in this way, we can convert any given mathematical expression consisting of irrational number as it is denominator completely into an equivalent expression whose denominator doesn't involve any irrational number. Here is the third problem, and in this third problem, it's a little bit more challenging than the previous two, because in this case, in the denominator, we both have root 3 and these two terms, root 2 plus 1. So in order to do this kind of problem, like before, we have to collect these two terms together, root 3 as one part and this part as the other part. And in order to use the mathematical identity that I have introduced to you a little while ago, I will call the one which is in this parenthesis to be equal to A, and the one in the other parenthesis that you can see to be B, so that eventually the product of the two terms will make our irrational denominator to be disappeared. Let us see what will happen when we multiply by using this formula, a squared minus b squared, which is equal to a plus b the whole squared, which is a squared plus 2ab plus b squared. This is a plus b the whole squared. But here, this one is a plus b times a minus b, which is simply equal to a squared minus b squared. So I'm going to use this expression in order to tackle this problem. So the given original problem is 1 divided by square root of 3 plus square root of 2 plus 1. And then I want to group them together so that this term will be a and the other term will be b. And I'm directly going to apply a minus b times a plus b so that the denominator consisting of rational number will disappear. So in order to achieve this, what I will do is, this is my given original expression, so that will be multiplied by, because in my identity here, a plus b must be multiplied by a minus b, or equivalently, a minus b is multiplied by a plus b. So here is my a and here is b, and they are joined by plus. So in the other side, they have to be joined by minus, so that the plus and the minus will finally give us a squared minus b squared. That's so good. So what we do next is, I will simply multiply by root 3 minus, the term in the bracket here is minus root 2 plus 1, divided by the same expression, so that this expression divided by the same will be equal to 1, and anything which is multiplied by 1 will give us the same thing. So 1 times root 3 is equal to root 3, and 1 times this expression, that is minus of minus root 2 plus 1 is minus times minus is plus, minus into plus 1 will be minus 1. And for the denominator, we will directly use this expression. As I told you earlier, what we do is we simply square the a term and the b term. And the square of the a term is root 3 squared, which is root 9, which is equal to 3, which is this part, minus the b term squared. The b term is minus root 3 plus 1, the whole squared, minus root 2 plus 1, the whole squared will be squared in this way, a plus b the whole squared, which is a squared plus 2ab plus b squared. So in order to be in line with the formula that we have in hand, what we need to do is, this is minus root 2 squared minus root 2 squared plus 2 times of the 2, 2 times minus root 2 times 1 plus the last term squared, that is 1 squared. So altogether, minus root 2 squared will be equal to 2. 2 times minus root 2 will be minus 2 root 2. And the square of 1 here is 1. So have a look at the one I wrote on the board here. Then, so here is root 3 plus root 2 minus 1 is from the numerator part, and from the denominator we can have 3 minus 2 plus 2 root 2 minus 1. And then I came to this part now, because 3 minus 2 is 1, 1 minus 1 will be 0, and I'm left with only 2 root 2. So still the denominator is not rationalized. Still I have root 2, which is still an irrational number appearing on the denominator. So once again I have to repeat the procedure by multiplying the final expression that I have now arrived at by root 2 over root 2 in order to cancel the root 2 term. So I'm going to multiply this given expression that you can see here multiplied by root 2 over root 2. Root 2 over root 2 means is equivalent to what? What? 1. Because in mathematics, always when we multiply a given expression by 1, it will never change, because root 2 over root 2 will cancel each other out, and we are left with only 1. So it is equivalent to multiplying the given expression by 1. So in this case, root 3 times root 2 will be equal to root 6. Root 2 times root 2 is root 4, which is 2. Root 2 times minus 1 is minus root 2. But for the denominator part, root 2 times 2 root 2. Root 2 times root 2 is root 4, that is 2, and 2 times 2 will be 4. Now everything is done in the right way, because as you can see it here in the denominator, now we are left with only a rational number. That is pretty good, because our original purpose is to eliminate an irrational term from the denominator, which we have eventually achieved, and that is the way this problem is done. So let us see another problem. In this problem, we have 2 divided by root 2 minus root 3 plus 1, which is the same as previous problem. But now what we have to take care of when we do this kind of problem is that if we make this part to be A and this part to be B, it will be a little bit more complex, and we have to reorganize the given expression so that it will be easier to solve the problem. So in order to do that, we have to bring root 2 and 1 term together, and root 3 alone to be another term. What I mean is, if we directly make root 2 to be the A part and root 3 plus 1 to be the B part, in order to use the formula that I told you a while ago, it will not function in the right way. We have to always take care of the way we have to choose our A and the B term. In this case, root 3 has to be, for example, the A term, or root 2 plus 1 has to be the other part. How do we know if this has to be the case or not? The way we do is root 2 plus 1. Root 2 square is 2, 1 square is 1, 1 plus 2 is 3 itself. That is root 3 squared is 3, and root 2 squared plus 1 squared is also 3. If this happens, this will guide us the way we have to group which one has to be the A term and which one has to be the B term. So this was our original problem, and this is, for example, our A part, and this part is our B part, as I told you, or the other way around, no problem. And then we are going to multiply the given expression by equivalent expression, which is root 2 plus 1 divided by root 2 plus 1. That is what we are dictated from the denominator part here. Root 2 plus 1 divided by root 2 plus 1 is already equal to just 1. So 2 times root 2 plus 1, and here I have plus 3 term, root 2 plus 1 plus root 3, and root 2 plus 1 plus root 3 term. These two terms can cancel each other out and be reduced into 1, and multiplying any mathematical expression by 1 is the same thing. So I'm going to multiply 2 by these two terms and the denominator by this term. So by doing so, we will get 2 into root 2 plus 1 plus root 3. You have to simply multiply 1 by 1, 2 times root 2, 2 times 1, and 2 times root 3. And also for the numerator part, because as you remember, we have already said a minus b times a plus b is always equal to a squared minus b squared. So our a is that part, and our b is this part, and the same term is appearing here. Here is minus, here is plus. That is the same as a minus b and a plus b here. So we are going to simply square the term here and the term there. And finally, what we get is 2 plus 2 root 2 plus 1 minus 1. You simply multiply each one of them term by term, as I have showed you earlier. And then finally, you get the denominator having 2 root 2. Is that the end of this problem? It must not be, because still in the denominator we are having root 2, which is an irrational number appearing in the denominator of our given expression. Our final target is in such a way that we have to find a mathematical expression which is equivalent to our original expression, but this time having a rational number in its denominator. So what we are left with is we have to eliminate the root 2 term now. So in order to achieve that, I have to multiply by root 2 over root 2, this final expression, the same being here, because root 2 over root 2 is 1. So when I do so, root 2 times root 2 is 2, root 2 times 1 is root 2, and root 2 times root 3 is root 6. So this is the final answer, 2 plus root 2 plus root 6 divided by 2. Now is the end of this problem, because now the denominator has only 2, which is purely a rational number as it is denominator. It means that we are done. So that is our original problem, and this is the final answer. And you can use a scientific calculator, not during exam, but when you study. If nobody is with you to assist you, if you did right or wrong, what you can do is possibly you can insert into your calculator this expression, and another time that expression, if they will yield you the same result or not. That is a kind of self-test and checking your answer by yourself. Here I have one final problem. It says rationalize the denominator of 1 divided by root 2 plus root 5 minus 2. In this case also, like in the previous example, 3 terms are appearing in the denominator of this expression, and we have to go ahead by choosing a to be root 5 and b to be root 2 minus 2. What makes this problem a little more challenging than the previous one is root 5 squared. If I square this term, I will get 5. 2 squared is 4, plus this 2 squared is 2. 4 plus 2 is 6. From the other part, I have 5, and from the other part, I have 6, which are not equal to each other. So the consequence of this is that I have to approach this problem partly by using my identity, which is a minus b into a plus b, which is equal to a squared minus b squared. But this will not bring me to a final answer. After some time, I have to re-rationalize it again, and we will see the details as follows. If I choose my a to be root 5 and b to be root 2 minus 2, with my mathematical identity that you should always remember is this one, which is a minus b into a plus b, which is equal to a squared minus b squared. This is my original problem. What I have to do is I have to multiply by the conjugate of my rational expressions. As you can see here, for example, if I multiply by root 5 minus of root 2 minus 2 and root 5 minus of root 2 minus 2, the numerator and the denominator are the same thing, so they can cancel each other out to become equal to 1. Every time we have to be very careful that whatever we are multiplying with our original expression will be in such a way that it will not affect the magnitude of the original problem. So it's equivalent to multiplying everything by 1. And here I have root 5 and joined by plus. This term, the a term, is joined by plus to the b term with this one. Here is my a term, and the b term is joined to minus here, as you can see. So it is exactly in the form of a plus b and a minus b. And then after a couple of steps, the numerator part is to be multiplied by 1. 1 multiplied by everything is the same, so it will be root 5 plus 2 minus root 2. And for the numerator, I have to square, according to this expression, I have to square my a term and my b term, so that everything reduces to 5 minus. You can do that by yourself because I showed you earlier, and it is pretty simple. You simply square every term, and 5 minus 4 minus 4 root 2 plus 2. And when you cancel out these terms, 5 minus 4 and 2, finally you are left with 4 root 2 minus 1. So in this expression, this root 2 is rational. Are we done then? No, because still the denominator of our given problem consists of irrational number, and then I have to proceed by eliminating this term, which is rational. But this moment, at least this problem is a way simplified, because in the denominator now we have 4 root 2 minus 1. So what we have to multiply with is 4 root 2 minus 1 times 4 root 2 plus 1. So here is the final expression, and then I will multiply it by 4 root 2 plus 1 and 4 root 2 plus 1, because this expression is the same as 1. And then we term by term multiply root 5 by 4 root 2, root 5 by 1, 2 by 4 root 2, and minus root 2 by 1, term by term. And then what happens is, for the numerator part, I will get root 5 plus 2 minus root 2, which is this part, to be multiplied by the other part, which is 4 root 2 plus 1. And then root 5 times 4 root 2 will be 4 root 10. Look, the way you multiply this kind of expression is that, for example, if I have root 5 to be multiplied by 4 root 2, I have 4, which is the coefficient, times square root of 5 times 2, which is 10, which is 4 root 10. And we multiply everything in this way. And when we multiply root 5 by 4 root 2, root 5 by 1, 2 by 4 root 2, 2 by 1, and also this term for the other two terms. And then finally, this is what we get for the numerator part. And for the denominator, I simply multiply 4 root 2 squared, because it is in the form of a minus b and a plus b. A squared minus b squared, 4 root 2 squared will be equal to 4 squared times 2, which is 32, and 1 squared, which is 1, so it is 32 minus 1. And then altogether, I will simply get 31 for the denominator by collecting similar terms and adding everything which could be added, finally I will get my original expression, mathematical expression, to be reduced to minus 6 plus root 5 plus 7 root 2 plus 4 root 10 divided by 31. This 31 is purely a rational number. This is purely a rational number, and I have achieved rationalizing the denominator of my given mathematical expression. This will bring us to the end of this lesson. Thank you very much. See you in the next lesson.